What's that mean? I'm gonna pop it back in. Oh, no. So swimming that year was a little difficult. I could only do so much, but I was able to do a front or freestyle and pretty much nothing else because the amount of rotation I had was next to nothing. So backstroke fly and anything like that, it's terrible. So when we got to state swimming, over in Laramie, where it was held, our team was only about 10 people. So come out and she's like, all right, we have a relay team and everything. Pop my shoulder out of place again. My swim coach, Mr. Scribner, looks at me, he's like, well, Robert, have fun out there. What do you mean? You can still use your left arm, right? No? Oh, wait, it's your right one. Okay, use your right. So I'm just still swimming with one arm. We lost the relay, but it was fun. I felt that memory just come back today. I'm just like, this seems very familiar. Took twice as long as it usually would for me. I'm just like, oh well. Alrighty. Pearson.
Here we go.
Do you have a computer, Raquel?
Yeah.
Okay.
Yeah, today we're doing computer stuff, so I can't just write on the whiteboard. Okay, so we are now looking at data. So we've been working with probability, and with our probability, a lot of that is going to carry over into data. Now, the good news is we're going to start with quantitative data, which everyone should be pretty familiar with. Quantitative data relates directly, all right, to, do you have a computer?
Yeah.
Yeah, okay. I was like, just want to make sure if you don't have one, you can share, but if you have one, you're good. So quantitative data, we need to like graph it, look at it, but this is all numbers and things that we're very, very familiar with, right? Means, medians, and modes. Just like with probability, the 3 rules of data analysis: make a picture, make a picture, make a picture. Everything we're going to do is all about making pictures. Our biggest picture that we're going to look at, all right, is a histogram. Histograms display our data visually so we can actually identify the shape, because with different shapes, they require different analysis. But the good news is we have a very, very standard picture that we're going to make, all right, and that'll tell us what statistics to calculate. Similarly, dot plots and stem and leaf plots are like histograms, but you can basically almost do those by hand. And of course, StatCrunch is going to do all of this. So the first thing we need to do is we need to go into StatCrunch, right? Make sure everyone can log in and see where all the data sets are going to be. All right, so in StatCrunch, all right, log into your StatCrunch. And then we're going to search data, data sets, and then bulk workings. And I'm going to show you that as well. All right, so when you pull up StatCrunch, it should look like that. All right, so give everyone a minute, make sure we get logged in. All right, you're Pearson, right? Get in your Pearson.
Is the right spot, right?
Yes. I was like, yeah, but I mean, it's your Pearson login.
Is there a space in Global Corkins? Or is it all in this?
One word.
Just
Are
one
we
word?
on the same like book we have, or is?
No, just BEAU.
E-
A
Oh,
U CORKINS. And then switch that to username.
Oh, okay. Roger. Not keywords.
Not keywords, yeah, you gotta switch that to username, yeah. That's the big thing, that being username, and then, yeah. And then we see we have 12 pages of data, so 12 pages of data. And that's basically the data we're gonna use for this entire course. We're not gonna look at all of them, don't panic. All right, some of those are stats too.
oh.
We are gonna look at a lot of them though. It was like. Oh yeah, that's so much data. That's funny. All right, and basically, okay, so that process, all right. We're gonna do that every activity, every quiz, everything, so make sure you have that written down. You haven't done your Pearson yet? No? Okay. All right, sit next to Denise, so that way you can see the StatCrunch
Go
stuff.
over there, mister, and think about what you've done.
I know. Well, I mean, take your notes or whatever you have, like, so just when we're doing StatCrunch stuff, just so you can follow along. Yeah, and get signed in for Pearson. You can get a 14-day free trial, so you don't have to purchase it yet.
She'll be back in 4 minutes.
Okay.
Sorry.
Okay, so along those lines, all right. I want to look at the tuition data set, and this is quantitative data, right? So quantitative data,
Statistics in here?
yeah, the technology in 131 is.
Okay, I'm like, why are you in the chemistry room? I was so confused. Don't blow things up.
So tuition is quantitative data, all right? And basically, again, something I could take an average of, makes sense. All right, this is, the year is actually, the way it's written is categorical data, because it's just saying this year period. From there, all right, so I want to make a dot plot, histogram, and stem and leaf. All right, and we'll do this in StatCrunch in just a minute. The histogram is going to look like this, all right? The stem and leaf plot looks like this, and the dot plot looks like this. Like I said, those are both, the stem and leaf and dot plots are basically just bad versions of a histogram. Histogram is what we're going to calculate most of the time. All right, so in StatCrunch, find the tuition data set. Okay, there it is. It was on page 10 for me. All right, so tuition data set, and then StatCrunch is really, really nice how this works. So we go to graph, and notice we have the options, all right? Histogram, stem and leaf, and dot plot, all right? So we have those three options. So let's go to our classic one, and it's actually really, really simple. I go in there, I click tuition, and I hit compute, and it is that simple. Similarly, graph, stem and leaf plot, tuition, compute. Now, just so you know, like I said, histogram, it's just so much easier to see the shape. But what a stem and leaf plot is, all right? So it has the hundreds, all right, or in this case, I think it's the thousands, all right? And basically it's a histogram turned on its side with actual numbers. It's there if you want to use it, as is the dot plot, all right? But the best way to find shape is actually using a histogram. So we went into the data set tuition, so go back to my list of data sets and then find tuition here. Scroll through the pages. Yeah, find tuition and then make a histogram. All right, did we make it, Denise?
No, I'm not.
Okay.
Sign in.
Yep, there's tuition.
Yeah, but
Oh, yeah, you gotta sign in. Yeah, so what's your Pearson, whatever your Pearson sign in is.
Sorry,
Have you signed up for Pearson? You didn't sign up either?
no,
Have you started the homework?
I look at it.
Well, if you were able to see it, that's your sign in. So also go into your Canvas.
Here.
So from your Canvas, right? Yeah, if you go to StatCrunch, you can click that link right there. And that should be, you should auto sign in from that. Yeah, see, there you go. So then, yeah, open StatCrunch. I mean, that's just a
Oh.
blank page, so yeah, there, and then you go data sets. Then do the Bo Corkins thing again.
And then what type of graph? Oh,
Yeah, so you can do it that way. So if you can't remember what your password is and can't get in from the site, just go into Canvas and then that.
Okay.
Yeah, so histogram is the main one.
I'm
Histogram,
blind.
yep, and then just click tuition. Click on tuition. Yep, see, and then it goes over and then just hit compute. And that's the graph.
Okay. Thank you.
Doesn't need capital C.
Doesn't have to be.
No,
Oh, here.
can all be, yeah, username and then search. Yep, there you go. And then now look for tuition due time. Oh, wait, was that on page
November
2?
10, right?
Well, for me, it was 10. It populates differently for, okay, might be on 10.
Yeah.
What page was it on for you?
On
Robert?
page 9.
Okay. Yeah, see, it populates slightly differently for everybody. It's really weird. There it is. So yeah, see, it was on page 10 for you. Yeah, it's super, it's bizarro. Okay, so then graph histogram. And then just click that in. Yep, click on tuition,
Okay.
like on tuition on the word.
Oh,
Yep. And then hit
Okay.
compute. All the way at the bottom right.
where has it gone? Oh,
And like I said, you can make the other two, but that's the one that we make 99.999% of the time. All right, we make a histogram and that's how we determine shape. Okay, so from that histogram, what are we going to be looking for? All right, what do we want to find? 3 things we're going to look at: shape, center, and spread. So we start out with what's the shape of the distribution? All right. Single hump, multiple humps, is it symmetric? Any unusual features? So the humps, all right, and bumps in the graph, we call those modes. Mode is a word you should be familiar with. Mode, as in the most frequently occurring value. When we use mode, though, all right, when looking at a graph, it's not the most frequently, but it's most frequent, like multiple possibly. So for example, this is what a bimodal histogram looks like. Bimodal means 2 modes. Now notice it's not perfect. When I actually draw this, it looks like that. All right, so when I kind of sketch over it, that's got 2 relatively distinct humps. Unimodal means 1 hump, and multimodal means lots of humps. The other case, when we have no humps, we call that uniform. Now, I know this doesn't look perfect. This is real data, all right? So this is where stats differs from math. So probability is the most mathy that we get, all right? Because in probability, we have values, we calculate them. It's very step by step, and the numbers work out beautifully. With real data, it is not perfect. So I know I see some little differences in this graph, but you're looking for what is the most distinct. All right. And that's pretty much the same all the way across, which is why we call that uniform.
Okay.
The biggest thing is you kind of stand back, you squint, and you look for the main shape. Okay. Do not get carried away in the teeny differences, right? This goes down to 9 and up to 12. That's only 3 values. What I'm looking at, I mean, this is basically 10 by 10. There's 100 data points here. It's never going to be perfect. This is also why we have that definition of practically independent, right? Because in the real world, no two numbers are the same, all right? So we have to live more in that gray. And I don't know what it is. It's all those years that everyone had in their math courses. And so we struggle a little bit with the gray, okay? So in stats, we're more approximate than perfect. Symmetry. Now, symmetry is a concept from math. Symmetric means that it's a mirror image of itself. All right. When something is a mirror image, all right, or approximate mirror image, again, not going to be perfect, we call them symmetric. If I look at these two graphs, all right, these are actually two graphs skewed in opposite directions, but this is about as close to perfectly symmetric as you get. The opposite of symmetric is skewed, which is what these graphs are individually. All right. If I have two different data sets, all right, a skewed data set has one or multiple humps and then tails off. We also, when we indicate skewed, we give a direction. So right skewed, the tail is heading towards the right, and we call that right skewed. Left skewed, the tail is heading towards the left, and we call that left skewed. You can also say that the right skewed is positively skewed because you're heading towards the positive numbers. Left skewed is negatively skewed because you're heading towards the negative numbers. Either one, they are synonyms, but when you identify something as skewed, we give a direction as well. So for a graph that is symmetric, the most commonly looking symmetric graph is what's known as unimodal. Approximate shape, all right, one big hump. Also, you should be familiar with this one. Does anyone know what that curve is called? It has to do with your grades a lot. A bell curve?
No.
Have you guys heard that term?
Yes.
No? Well, you're kind of lucky, all right? Because a bell curve is a particular commonly occurring way to curve classes. The problem with a bell curve is that it assigns particular percentages to each category, which means that let's say that all 5 of you the course finishes, all right, and each of you has a 90% plus in the course. Well, a bell curve says not everyone can have an A. I only give 1 A. That means there has to be 2 Bs and 3 Cs, right? So it has to be perfectly distributed, all right? And that has happened to me. Oh, it was so tragic. All right, it was in a class of 30 people. I'll never forget it. All right, it was stats, experimental design statistics 2. I was in a class of 30 people. All right, I had a 93% in the course, and I got a B because he said, "You're the 4th highest grade." I already had 3 A's. He did a perfect bell curve. All right, there were 3 A's. You had a 93%. That's a B. All right, he's like, "Oh, I was too easy." That means that, but he's like, "I only assigned this many A's," and so, just FYI.
Dang,
Yeah. So it still
that
haunts.
sucks.
That's 20 years ago, and it still haunts me.
Jeez.
All right, so we determine the shape. The shape then leads to, all right, the 3 M's, which you guys definitely should be familiar with. The mean, median, and mode. All right, the 3 M's are measures of center. Dependent upon the shape, their particular center is appropriate. The mean is not always appropriate. The median is not always appropriate. The mode is not always appropriate. It depends upon the shape. All right, the shape of the graph determines which of these we're going to use. We're going to talk about that in a little bit. but we're gonna talk about the three M's. So median. The concept of finding median by hand, all right, is you line all the data values up, all right, in order from lowest to largest, smallest to largest, and then the exact middle value is the median. This is commonly used terminology too. On a highway, that big center divide, what do we call that?
Median.
We call it the median because it is the middle of the road. All right, so this is commonplace terminology. Now, the good news, all right, and I could show us how to calculate this by hand. Probably you've done it. But are we ever going to calculate stuff by hand in the real world? No. What are we going to use in this class? StatCrunch. We just saw it. StatCrunch calculates all this for us. All right. So if you don't know how to calculate the median, if this description wasn't enough for you, go watch a video. But StatCrunch is going to take care of the calculation for us. Mean. All right. Mean is one you're probably more familiar with. That's summing all the numbers up and dividing by the total. Right? And in case you're unfamiliar with this notation, this we're going to see, that's big sigma. That's shorthand for sum. All right, so that means sum. All the values, divide by the total, that gets you the mean. Notice we have some notation that we're kind of familiar with. Y bar. This is not the same as probability. I know the notation is the same, but when dealing with data, we represent the mean as Y bar. Along those lines, the median, just so you know, we represent the median as X tilde or Y tilde, whatever. So that's median notation, all right? X tilde, all right? And X bar means mean. And lastly, the mode, the most frequently occurring value in the data set, all right? And that one, most of the time, you just look at the data set and find which one is the most commonly occurring. StatCrunch will also calculate this for us. So the three M's, mean, median, and mode, actually people are pretty familiar with. What we are less familiar with are spreads. So it's not just important to know where the middle, right, where the center of the data is, but how is the data distributed? How is it spread out? How far from the center is a particular point? We have three measures of spread, just like we have three measures of center. Each of these measures of spread pair with a measure of center. So we're going to talk about each one and then talk about the pairings. So range is the easiest one to calculate. Max value minus the min value. All right, largest minus the smallest, and that gives you the entire range of data sets. All right, this is also a word you probably remember from algebra. Range is the highest to the lowest value on the y-axis. All right, same exact concept. Standard deviation. Standard deviation is actually kind of a complicated measure of spread. It actually determines how many, all right, values away from the mean you are, all right, within a particular distribution. Now, this is the definition of why StatCrunch helps us. Notice this calculation, the square root of the sum of each value minus the mean squared divided by n minus 1, all right, where n is the sample size. That is just a horrific value to calculate by hand, all right? Not what we're going to focus on. We are going to focus on how to use these values and interpret these values, all right? StatCrunch is going to take care of the calculation. What we do need to know, though, is the relationship between variance and the standard deviation. And the good news is that variance is just the standard deviation squared. In the calculation, notice, all right, the calculation for the variance is that exact same formula without the square root. So if I have the variance or the standard deviation, it's just squared square root to get back and forth between them. All right, and lastly, the IQR or interquartile range. The IQR is calculated by subtraction of the percentages. The third quartile is the 75th percentile. The first quartile and quartile, what's kind of the dominant word in quartile? Quarter. All right, it means quarters. The first quarter and the third quarter. All right, the 25th percentile and the 75th percentile. The median is what percentile? The 50 percentile. So if you didn't notice already, IQR pairs with the median. All right, it orders the data and then it cuts the data in further pieces. So the IQR, which is actually just the subtraction of Q3 and Q1, the third quartile and the first quartile, it gives the middle 50% of values, which is usually where the majority of data lies. All right. And or it is at least most densely packed. So you can see where the data is most densely packed, and then it spreads out on the above the third quartile and below the first quartile. And so one big thing that we do is we create a 5-number summary, often when dealing with medians and such. Median, Q1 and Q3, and the min and the max make up what are known as the 5-number summary. And again, all right, we're going to look at an example here of just all these pieces and how StatCrunch just beautifully calculates these in a matter of seconds. All right, so I have 2 examples here. All right, we have the number of credit hours of 13 students, and number of piercings that 12 people have. Now I have an even and an odd data set just because technically the calculation of the median is different for even and odd data sets. Also, this is going to allow us to practice using StatCrunch and put in values. All right, so I'm going to go back to actually my home page. And if you need a blank page, so we don't have a data set for this one. If you need a blank StatCrunch page, you hit the big yellow button and it opens just a blank data set. Now I want to enter, all right, my credit hour data and my piercing data. And then just be aware you can go up here and you can give them titles. I'm call this one credits. And this one piercings. So, all right, entering a data set. Now, the good news for us, we're never going to have to enter more than like 20 data values, but you should be able to type these in and do these. If the data set ever gets bigger than 20 values, I'll give you the data set. All right. I don't want us wasting a bunch of time, but it's good to kind of, you know, be aware and be able to do this. Enter some values. It's pretty simple. Double check our numbers. I was like, let's make sure we entered everything correctly. Human error is the only issue that we really have. 20, 20, 20. 15, 19, 17, 15, 10, 18, okay. 5, 3, 7, 2, 8, 7, 0, 11, 0, 5, 0, 0. All right, and so human error is the only thing, so make sure you enter your values. Okay, so summary stats, columns. I'm gonna just do these both at the same time, so I'm gonna click in both credits and piercing. All right, so for you guys, you need to control click, all right, to make sure you get both of those in there. Stat, summary stats. Oh, okay, you're there. All right, and then control click to make sure you get both of them in there.
Like that?
Oh, no. So stat, gotta go to stat. Stat, summary stats, columns. And then control click that. Yeah, control. There you go. See, if you just click one or the other. Okay. Then, okay, so in the statistics, so it auto has a bunch of things highlighted and you have to scroll through it. Now, as a note, unclick standard error. Then scroll down, click in IQR, and click in mode. And then hit compute. Now you have to control click, otherwise it unhighlights everything. Which, yeah, yours unhighlighted here, so just start again, because otherwise it's too much of a pain. So stat, summary stats, columns. Okay, credits, piercings, control click. Okay, now control click standard error. Okay, scroll down. This is where a mouse is really nice. Okay, so scroll down, control click IQR. Scroll down and control click mode. And then hit compute.
Okay.
Did you get it? Okay, so then hit compute. All right, and yours does look like mine. All right, so then make sure yours looks like mine and notice what it gave us. N, this is the sample size. I had 13 values for the credit data, 12 values for the piercings. Mean, variance and standard deviation. What's the relationship between variance and standard deviation?
You say between variance and standard deviation?
Yep.
Variance is standard deviation squared.
Right, square root, right? If I'm looking for this one, square this one. If I'm looking for this one, square root this one. And then median, range, min, max, Q1, Q3, IQR mode. That's all of them. All right? No hand calculation. Also, we talked about 5-number summary. Okay? Min, max, Q1, Q3, and the median. Those 5 values create the 5-number summary. All right? Because it breaks the data into quartiles. Min is the 0 percentile. Q1, 25, median, 50, Q3, 75, maximum, 100, right? 0, 25, 50, 75, 100, right? So all the data we possibly need is right here. And that's why this is really, really nice. Now, this one actually did have modes. All right, so it said the mode was 15 and 0, 15 for the credit data, 0 for the piercing data. Sometimes that says NA, and that's when all values are distinct. So if that happens, that means you could say it 2 ways. There is no mode, or all the data values are modes. All right, either way is correct. All right, so all right, no hand calculation. I mean, I just love that. StatCrunch, I was like,
It's much better than Excel.
oh, yes, absolutely. StatCrunch is far superior to Excel. This is not the last time that we'll prove that.
It's my job a heck of a lot easier.
Okay, so I ran through that, and just as FYI, so what we just did here, stat, summary, stats, columns, control click, standard error, mode, and IQR. That's the same. This is what we're going to do every time you need any data, all right? And we do this a lot. Okay, so I was just talking, I said, okay, well, we can that calculated all three centers and all three spreads. But there is a problem. Having too much data is, or having too many numbers is just as problematic as having not enough. So we need to actually identify, in what situation do I use what value? I don't want all three centers and all three spreads every time. In order to do that, we have to create a histogram. So graph, histogram. I'm going to click in both of them because it'll just make them one after the next. Okay, so my credit data set. And with small data sets, it's kind of hard to determine a shape. So again, approximate best guess shape. Okay? Is this unimodal, bimodal, multimodal, or uniform? How many modes do you see?
2? No, 1.
Yeah, again, squint and kind of turn your head. There's really just one, like that's all that really is.
There's not a large enough number of.
Right, to actually compete with it. I mean, 3 and 4 are actually pretty close.
Yeah.
I was like, so the approximate shape here, all right, and then does this look heavily skewed or symmetric?
Symmetric.
Symmetric-ish, not perfect. This is real data. Real data is never going to be perfect. All right. One other. Okay, hold on. Let's look at the other one. See if it's more dramatic. Okay. This one is much more clear.
Yeah.
Unimodal, bimodal, multimodal, uniform.
Wouldn't it be bimodal?
So 2 modes here. How many peaks?
Oh, no, there's only one.
1 peak means unimodal. Is this symmetric or skewed?
Skewed.
What direction?
Right.
To the right. So this one's much more obvious. Okay, let's go back to our data values. Okay, I'm just shorthanding this, not getting the rest of it. When you compare the mean and the median, if the mean and the median are close, all right, that is at least a semi-helpful indicator, all right? If you're on the cusp of what is the shape of this, if they are close, that is a helpful thing to identify that the data is symmetric. So I can't remember which one we were looking at. Was it the credit data?
So how close would the mean and the median be?
That's an excellent point. It's data specific. If I'm dealing in billions and something is a million apart,
Doesn't really matter.
it's probably close. If I'm dealing in minuscule decimals, all right, and 0.01 might be hugely far apart. There is no hard and fast rule. It's a matter of looking at the picture and then looking at the data in conjunction with it. And this only ever matters if you're kind of on the cusp, because the biggest thing always comes down to people want to say everything is skewed when actually most things are symmetric. All right. And actually in both these cases, the mean and the median are approximately the same. But notice that one of those graphs we saw actually looked really skewed. So look at the shape first, then look at the data second. So that one that we were on the cusp of, in both these cases, the mean and the median are about the same. So. Okay, so which one was the skewed one?
That would be the frequency and piercings.
The piercings data? Okay, so the piercings data, unimodal and right skewed.
I get it. I get it.
The credits data was unimodal and symmetric. Now again, not perfectly symmetric, just approximately symmetric, right? About as symmetric as we can get. All right, we found all the measures of center and spread, all right, for both of them. And then just for practice, I want to write the 5-number summary.
I
So the 5-number summary, all right, is the minimum, Q1, median, Q3, maximum. All right, so I wrote these upside down. Okay, so for the piercings, all right, minimum 0 and 10 for credits. 0, 10. All right, and then just read me the values. For Q1, what for piercings, what's Q1?
0,
0. Median of piercings.
4,
Q3
7,
and maximum.
11.
And then similarly for credits.
Credits. Ooh, I lost my grip, hold on.
15,
What is it? 15? Median.
16,
Q3
There we go, it's back.
19,
and maximum.
20.
Okay, good. So we see what we're reading off there, right? And again, the 5-number summary is really nice because this is the 0%. This is the 25%. This is the 50%. That's 75%. And that's 100%. You need 5 values in order to break the data set into quarters. And so that's why presenting the 5-number summary is a very, very common approach because it just breaks the data set into these nice chunks and you can see relationships. 25% of the credits data are values between 15 and 16. All right. Almost 50% of the data of the piercings data set is 0. All right, because when you have a repeated value like that, 0, 0. But again, all right, regardless of what's being asked for, all right, 5-number summary or just a center, just a spread, whatever it is, all right, StatCrunch can take care of that. Now this brings up a note on your home fund. My Pearson pretends that you don't have StatCrunch and it says to calculate everything by hand. Don't waste your time. All right. There's a little blue box next to a question. That's how you open up StatCrunch. Okay. So it's a little blue window, all right, that you might not see initially. So on each problem, open that up and it says open StatCrunch and then just do what we did. Okay. So don't waste your time calculating anything by hand.
That answers my question at the end of class. Never mind then. Okay. Makes it a lot simpler.
Yes, absolutely. All right. Pearson, for some reason, like it gives you access to StatCrunch, but all those questions, when you do view an example, it always shows you how to do it by hand. It's a total waste of time.
Well, Garrett and I were working together on them and we got a little ahead of ourselves. So about problem 60 came around and we're starting to do this and working through every little one of them. It's just like, why?
Yeah.
There has to be a better way. There is.
Yes, there absolutely is. All right. So along those lines, what we are going to focus on, all right, is actually calculating and not calculating, displaying information and interpreting the results. StatCrunch handles the calculation. Stats is about explaining, communicating, interpreting, all right? Which is the part that most people are weaker with but I just said that we don't have to do any calculation. And everyone's always like, no. I was like, actually, like, I'm really good at this. Yes, so is the computer. It's actually better than you are, all right? So we're going to focus on interpreting. One of the biggest things that we need to know how to interpret is a box plot. So this is another type of display that StatCrunch makes for us. I am going to make this one time by hand because the pieces within it you need to be able to understand the pieces within it so you can interpret the results. All right, so the basic idea of identifying a box plot, you calculate Q1, the median, and Q3, which we're going to get from StatCrunch. That creates the box part of a box plot. The box part of a box plot is the IQR. It is a measure of spread. The middle line in a box plot is the median, the middle of the data. Going off of the box plot, all right, in both directions is what's known as the outlier rule. Q1 minus 1.5 IQRs and Q3 plus 1.5 IQRs. So basically, the IQR, which is the measure of spread, representing 50%, all right, the middle 50% of the data. 50% times 1.5 is 75%. Q1 is the 25th percentile. 25 minus 75% is negative 50%. Similarly, on the other end, 75 plus 75 is 150. In order to be technically defined an outlier, that means you are 50% below or 50% above, all right, what the data set considers to be the reasonable 100% mark of how this data should be distributed. Which means this rule is very generous. If you're an outlier, you are very far away from the main set of data. And that's how the outlier rule is determined and how those values are identified on a box plot. Then grow your whiskers, all right, to the highest and lowest value within, all right, and that highest value and lowest within the fences, and that determines the rest of the box part of a box plot. All right, so along those lines, let's look at an example. I want to consider the following data set, which lists the top 10 hockey players with the most assists in an NHL career. I want to create a box plot by hand, and then we're going to do it in StatCrunch, all right, for interpretability. So for ease of calculation, these values are actually already in order, all right? So we can actually find our median Q1 and Q3 actually by hand, super easy here. All right, so I have 10 data values, which means the median is the value right here. And when the median, and this is what I was talking about with even and odd data sets, when the median is in between these two values, the easiest way is to add the two together and divide by 2, right? To find the exact halfway point in between two values. And that number is 1107. Then the first quartile, that's the middle quarter. And basically, I'm just looking at the bottom half of the data set. Since there's exactly 5 values, that means that value is the first quarter, and same thing, that value is the third quarter. With a small data set like this, and they're already organized for us, super easy to find these by hand, okay? The bigger the data set, the worse this is to find by hand, which is why we have technology. And then obviously, actually, while we're at it, there's the minimum, there's the maximum. And look, we found the 5-number summary, and that's what it is. Okay, so now let's do the box plot part. The IQR is Q3 minus Q1. That is 1193 minus 1043, 150. All right, I need to create the fences. The upper fence is Q3 plus 1.5 IQRs, which is 1193 plus 1.5 times 150. And I need the lower fence, which is Q1 minus 1.5 IQRs. Okay. So in order to do this by hand, we need those couple of pieces of info. And now we're actually ready to draw the box plot. Okay, so. All right, the first part of drawing a box plot is we need to make the box part. Q1, median, Q3. So Q1 was 1043. The median was 1107. And Q3, 1193. All right, that gives us the box part of our box plot. All right, Q1, median, Q3. The fences, all right, that we found, which was the outlier rule, that 818 and that 1418. That represents where the data should exist, all right, if there are no extreme values. Then we draw out to the highest value within the fence and the lowest value within the fence. These create the whiskers. All right, so 818 is our lowest value, is our fence. 1018 is actually our lowest value. So the whisker only draws out to 1018. All right, let's use a different color. On the bottom side. So actually it only goes out that far. The highest value within the fence above is 1249. That's not the highest value. The highest value within the fence is 1249. All right, so the lowest value within the fence, highest value within the fence. Then anything below, all right, our lower fence or above our upper fence is considered an outlier. And we clearly see we have Wayne Gretzky, 1,963 assists. What is Wayne Gretzky's nickname? Does anyone know? Outlier. I mean in hockey. Does anyone know? He was called the Great One. Does this look like he's great statistically? Uh-huh. Yes. All right. And so then up here at 1963, we identify a point star, asterisk, dot, doesn't really matter. All right. And that indicates an outlier. All right. So again, I did this by hand just that one time because a couple of things. When we talk about, is this point an outlier? The term you use is, yes, the value is outside the fence, or no, there are no values outside the fences. All right. The other big thing is that actually StatCrunch, when it creates, you don't see the fences. That's why I drew them with dashes. All right. They are invisible lines. It says, all right, that it's going to use the fences, but you can't actually see that. All right, so let's go to StatCrunch. All right, now I'm just gonna add another column here. All right, I'm just gonna call that hockey. All right, graph. Box plot. I'm gonna select in hockey. And notice, it says use fences to identify outliers. That is automatically clicked. Okay, so you don't have to do anything with it, but that determines how that, the justification of what is an outlier or not. And then just so it kind of matches what we just made, I'm gonna say draw the boxes horizontally. And then hit compute. Does that kind of look like the graph we just made? Yes. All right. About 1,000 to 1,200 was where everything was, and then one outlier. Okay. I can't do it on the iPad, but hover over that blue region on your computers. What do you see?
Number of values, number of outliers, IQR, lower limit,
Just hover.
Q1, median,
Yeah,
Q3.
right there. Okay, hover.
What's
Don't click
that?
anything. Yeah, done.
Okay.
Just get there, right?
Okay, okay.
Sorry. So, yeah, you see, so notice all the data that presents. All right, Q1, Q3, median, upper limit and lower limit. Notice that those are not the fences. That is the highest value within the fence and the lowest value within the fence. All right, so when it says, what it's calling upper limit, that's what we're calling the highest value within the fence, lowest value within the fence. So it gives you a lot of information, all right? But the big part is knowing, right? Where's the minimum? That value. Where's the maximum? That value, all right? The box part of a box plot is the IQR. That's Q3, median, Q1, median, Q3, all right? So understanding everything that's there, StatCrunch is gonna do all the work. We're never gonna calculate by hand again. I just do it that one time so you can, so when you look at this, it's not magic, all right? It is something we could do. All right. And so again, very nice. Oh, and then you can see all the highlights. So actually on your graph, if you're trying to find that Wayne Gretzky point, you could just drag over it and highlight, and then you can go back to your data set and it would highlight and say, oh, what was that number? That was 1963. Okay, so we have making histograms, all right? We have calculating all those summary statistics. We have creating box plots. Those two graphs and those calculations, that's basically everything for, all right, the picture and calculation part of quantitative data. What we then need to do is actually identify when to use which measure of center and spread. When you have unimodal and skewed cases, we report the median and the IQR because they are resistant to outliers. When we say resistant to outliers, we don't mean there are no outliers. It means their calculation is resistant. So for example, if I have the data set, 1, 1, 1, 1, 1, 1, 1, 1, 5 million. What's the median of this data set? then I don't need a computer. Where's the middle value? What is it? We don't know. It's in order, right? In order to find the middle value, count in.
Even in mind, I miscounted.
1. The median is 1. In order to find the mean, I add all these up, 5 million plus 10-ish. All right, then divide by 10 values. So the mean of this data set is like 500,000. Is 1 or 500,000 a better representation of the center of this data set?
500,000.
No, 1. Where's most of the data? It's 1. 9 out of the 10 data about 1, 2, 3, 4, 5, 6, 7, 8 to make it 9. All right. 9 out of the 10 data values are 1, which means the best representation of this data is the number 1. All right. Just because there's one single extreme value in there doesn't mean that that's not where 90% of the data exists. All right. And that's what we mean by resistant to outliers. We saw in the calculation, median is the 50th percentile. The IQR is made up of the 75th and 25th percentiles. So this measure of center and spread are always paired together. Similarly, the best measure to report when you have unimodal symmetric data sets is the mean and standard deviation. This comes back to the concept of the bell curve. And it's because, all right, now my reason is they have, quote, nice properties. We actually spent a very long time talking about what all those nice properties are. And it's that the data set breaks into wonderful percentiles, similar to what the median and IQR do, all right, but even better, all right, when you have unimodal symmetric data sets. All right, like we already talked about, if you're confused, all right, if a data set is symmetric or skewed because it's kind of not great on the histogram, compare the mean to the median. If the mean is approximately equal to the median, the data set is likely symmetric. All right. And then don't forget, mean much larger than the median or vice versa. Remember your alligator, right? Alligator eats the bigger number for the inequality. You guys remember learning that as kids? The alligator eats the bigger number because it's hungry. Okay. So for extreme values, all right, we have skewed data sets. All right, and I'm going to summarize all this in just a minute. And then lastly, for bimodal or multimodal cases, you can't choose the mean or the median. That's when we use the modes. And it's not just mode, because by definition, bimodal means 2 modes. So you have to have multiple modes and the range as the measure of spread. Okay, so let's summarize what I just said then. It all starts with shape. The most commonly occurring shape in natural phenomenon actually is unimodal symmetric, the bell curve. The appropriate measure of center and spread is the mean and standard deviation. Then every time you need a reason. So again, at the current moment, that reason is they have nice properties. The next most commonly occurring shape is skewed, unimodal, either unimodal left skewed or unimodal right skewed. All right, they both occur. They both occur very, very commonly, not as common as unimodal symmetric, but these occur very, very commonly. The appropriate measure of center and spread is the median paired with the IQR. We use those because they are resistant to outliers. These three shapes account for well over 95% of all data sets that exist. Okay? Notice mean standard deviation paired together, median IQR paired together. Then we have the last, all right, measure of center and spread. Those are paired together. You never have them crisscross. Mean is never paired with IQR. Standard deviation is never paired with the modes. All right. So that's an important thing because people are always trying to crisscross them. They're always this center with this spread, this center with this spread. All right. And lastly, bimodal or multimodal. All right. And actually, bimodal or multimodal, symmetric or skewed. Okay. This is way less than 5% of all remaining data sets, but everyone wants to describe data sets as bimodal or multimodal. All right. And it's all about because you're looking too in depth. Only if you can come up with a very good reason that is data specific, all right, should you identify something as bimodal or multimodal. This is when we use the modes, plural, and the range. And the reason, like I said, the reason will vary, but always data specific. And what I mean by that is it relates to the context of the data. If you can't think of a reason that that data set, all right, is bimodal, then you shouldn't be identifying something as bimodal or multimodal or whatever. This is the most difficult case, but also by far the most rare. All right, let's look at some examples and let's see what we're talking about. So I have the Singers data set, heights in inches of 130 members of a choir, StatCrunch. It's in, okay, StatCrunch data set, data activity column Singers. I want to describe the shape of this distribution, appropriate measure of center and spread. We explain the distribution? All right, data activity column Singers. All right, it was on page 6 for me. All right, so lots of data, lots of columns of data. All right, we're just looking at the column Singers. All right, which represents the heights of a bunch of singers. Is that what it said? Heights of 130 members of a choir. All right, so our first foremost step is make a picture. Our new picture is a histogram. So we go in, we make our histogram.
Working my way back.
Did we find it?
You said it was on the sixth.
It was on 6th page for me.
Singers.
I know you can, it's so easy to scroll by. It happens to me all the time. Back to page 1. Did you find it, Robert?
Working my way back. I might have scrolled past it. Just using Control F so my eyes are rough without my glasses. Not going crazy. Huh, 6 hills. Interesting.
Oh, there it is. It's the top one. It's the very first one on page 1 for him.
Huh.
No, it's right there.
Oh.
Different?
Yeah. Oh, man, right? When it's the very first one on page 1. Okay. All right, so histogram, singers. And then, all right, we always start out. What is the shape of this distribution? It's right here.
Okay.
Hey guys, graph.
Did you say you were using them?
Just singers, yep, just singers.
Yeah.
All right, and what is the shape? So we're gonna start unimodal, bimodal, multimodal.
Unimodal?
I would probably say unimodal. Okay? Symmetric or skewed?
Symmetric?
Yeah, symmetric-ish. Maybe a touch, right, skewed. Doesn't really matter. Okay. That's exactly how I would describe it. Except then you think, okay? I say, okay, I see a hump that's not super big. Is there a reason, context, that the heights of 130 people in a choir would have two kind of distinct different heights? What is if I compare two people and their heights are drastically different, what is the difference between those two people, likely?
Usually by a foot, if they're really small.
Is it just, is there something more generalized? What is the biggest difference between people?
Inches, centimeters.
Not actual difference. If I have any two individuals. Go ahead. Gender.
Wow.
Is there an average difference in height between men and women?
Yeah.
Yes. All right. The average height for men is 5'10". That's about 70 inches. The average height for women is 5'5". That's 65 inches. All right. So unless you can think of a value, and it always comes down to something like that, okay? Just generalized differences, all right? This is the one case, and so that's what I was talking about. This is the exception, all right, that we're looking at here. I think this actually is bimodal because, reason data specific, because there's an average difference in height among genders. So this is the one case where I would say, okay, I'd say it's bimodal. And we said you can quantify it slight right skew. All right. When I have a bimodal data set, the modes, the appropriate measure of center and spread are the modes and the range. Modes at 65 inches and 70 inches. And range equals, number we'll look up in a minute. All right. And basically the last piece is reason. Bimodal, since average height differences among genders. And so the reason is data specific. So notice, right? If I was just looking at a, let's say, contextually blank data set there, I would have said, this is unimodal, slight right skew. Unless you can think of a legitimate reason, right, that the data set is bimodal or multimodal, you should never identify them as bimodal or multimodal. And I point this out because people are always, we just focus too much on the details. Most of the time, stand back, squint, and like I said, I would have initially identified that as unimodal, slight right skew, and been done. I take a minute and I think about it and I say heights. Is there a reason that I have two distinct heights? And yeah, I was like gender. Always, that's one of the biggest differences when it comes to anything. Is there an average difference in weights among men and women? Yeah, for the same reason, right? I was like, so, all right. And then in fill in, and then I want to make sure summary stats, columns. I need to find singers, and I'm not going to do it all because I'm really just looking literally for the range. The range is 16. All right, so we have 3 cases. All right. Always, whatever that shape is, it'll pair with a particular measure of center and spread, which then pairs with a particular reason. And that's the biggest thing that we do. That's the interpretation part. StatCrunch did all the heavy lifting. It calculated the graphs, right? It computed all the numbers, all right? We do this part. And that's primarily what we're going to do. All right, let's look at a few more examples to practice this. 16 gas stations in Ithaca, New York posted these prices for a gallon of regular gasoline, StatCrunch data activity, which we're already there. All right, column gas prices, appropriate graphical display, et cetera, et cetera. All right, graph, histogram, gas prices, compute. I think we won't have nearly as much discussion on this one. What is the shape here? How many modes?
Unimodal,
Unimodal?
right skew.
Right skewed. All right. Thinking about gas prices. Okay, first of all, does anyone see anything that could even be a second bump? No. So there is no even point in discussing, could this be bimodal? This is obviously unimodal, right skewed. Actually, technically, that was B, make the graph, then appropriate center. All right, the appropriate center is the median. Appropriate spread is the IQR. All right, we'll get those values in a minute. And both of them have the same reason, because they are resistant to outliers. The best part of those first two cases, mean and standard deviation, median and IQR, the reason never changes. It is always they're resistant to outliers or they have nice properties. Bimodal and multimodal, that's the one that answer changes all the time. But these reasons are always the same, which is why actually you want to describe things as unimodal skewed or unimodal symmetric. All right, let's go to our data. We need our actual values here. Stat, summary stats columns, gas prices, and now I do have to adjust it because I need the IQR, which doesn't come up unless I fix it. Okay, so the median 3.084 and the IQR 0.09, 3.084. 3.084 and IQR 0.09. Gas prices. And so I think technically that is prices. I'm assuming it's dollars. All right. Are there any outliers? Be sure to use the rule, create a box plot. Does this agree with what you found? So the outlier rule is really just the fence rule. UF and LF, upper fence and lower fence. That is Q3 plus 1.5 IQRs. Q1 minus 1.5 IQRs. StatCrunch gave us the values. So Q3, 3.149, 3.05, 3.149, 3.059. Okay, so the outlier rule is really just the fence rule, which is a calculation, which is not difficult, and StatCrunch did most of the heavy lifting for us. Didn't do it all right? But basically the rule says, all right, is there any value below the lower fence or any value above the upper fence? If there are, those are outliers. Now here's the problem part of using the rule. So I have the value 2.924 and 3.284. The only way to actually use that is to go back and look at the data values. So the good news, are any of these values have a 2 in them? So there is no value below the lower fence. 3.284. Are any of these values above that? Oh, there's a 3.2. Nope, 6.9 is below. Nope, below. No, we're good. So, are there any outliers? No.
But you would still have to mark those on a box graph if you did it.
No, that's actually all you need to do. But here's my real point. That was only 16 values. What if you have 1,000?
You'll have some.
Yes, but you don't know which ones. The much faster way is just create a box plot. Gas prices, compute. Are there any outliers? How do you know?
There are no outliers showing up.
I mean, what would you see visually? What do you not see here?
Dots.
Yeah, dots. There's no dots, up here, right? So the box plot is the much faster way. Now, be aware, our justification, right? There are no outliers. Since all values fall within the fences. So I never actually do that calculation. I look at the box plot and I say, oh, there are dots. If there are dots, highlight them, find that point. That's an outlier. All right. If there are no dots, then all values fall within the fences. But always make sure in your justification, either all values fall within the fences or there are outliers. These values fall outside the fences. Okay. So not a good description is there are no outliers because I didn't see any on the box plot. That's not the appropriate logic. All right. So make sure you actually discuss fences. All right. And that's why I did it by hand. And that's why I pointed that out. That in StatCrunch, it even says use fences to identify outliers. Because actually in our justification, it is about the fences, which is the outlier rule.
So on the exam, will you have us make a box graph then?
Yeah, I'll be like, well, usually I just say, are there any outliers in this data set?
Oh,
Right? And you should know, how do I find my outliers? A, I can do it by hand, or B,
just look at the data.
I can make a box plot. All right. Okay, so comparing groups. So StatCrunch is all about, statistics is all about actually comparing groups. One of the best things that StatCrunch does is it makes what are known as side-by-side box plots. It creates two graphs on the same coordinate system. Okay, a side-by-side box plot does not mean make two box plots and put them next to each other. They will always look the same, and it doesn't matter if the scale of one of them is in millions and the other is in billions. Side-by-side box plots mean that two or more graphs are on the same coordinate system. So I want to look at this data set. I have 100 US women and European women recorded in the data set, US and European women's heights. I want to compare the heights and describe the differences. And I identify this because when we compare data, there's two big things we need. Well, three big things. The two biggest ones are the same ones we've just been talking about. You compare centers and then you compare spreads. All right. And it's really just about making a sentence regarding that. And the other big thing is discuss outliers. Okay, so US and European women's heights. All right, so back to our data sets. US and European women's heights. All right, so I have the data sets there. Graph, box plot, and then I'm going to click them both in. All right, because it puts them on the same scale. And this is how I could actually make some comparisons. All right, did we find the data?
Looking.
Yes.
Ooh, found it.
All right, graph, box plot. And then control click. All right, excellent. All right, compute. Okay. So comparing centers. Where's the center on a box plot?
The middle line.
That middle line. All right, so looking at those two middle lines, they look pretty close?
Yes.
Yes. All right. Where's the spread on a box plot? What part of a box plot represents the spread?
The blue sections.
The blue part, the box part. So how does this box part look to this box part?
The one on the right looks slightly bigger.
Right, European women's heights are slightly more spread out than US women heights. All right, and then one last thing. Are there any outliers? Nope. Yes, there is a dot right there. And then highlight that dot and identify that value, which is 200 centimeters for your European women. Those are the three things, all right? When comparing groups, those are the three things you talk about: center, spread, all right, and outliers. Outliers are super easy to identify. The spread is the box part, so you compare all the boxes of box plots. And then the center is that middle line every time. All right, let's write that up.
How's the semester starting?
More than just like. High, low.
So when writing this up, right? US and European women's heights have about the same median height, the center. However, European women's heights are slightly more spread out, all right, or more variable, however you want to word that, are more spread out than US women's heights, right? Just simple comparisons. Notice, I barely have any numbers here. The only number I actually identified was my outlier. We noted a European woman with a height of 200 centimeters, which was an outlier, all right? These are just the most basic level of conclusions because this is the most base level of things that need comparison. And you can get more detailed, which is fine, but you have to talk about center, spread, and outliers. When comparing groups, center, spread, and outlier. People get way too caught up comparing this one value to this one value and this one value to this one value, mins and maxes. And I was like, notice I'm really just comparing like even IQRs. I could even say that the IQRs of European women were larger than US women IQRs. All right. So I'm very, very general, but I'm making statements that are actually useful. And that's the big thing. General, but helpful. All right. All right, one last example here. A student conducted a study on the effectiveness of various coffee cups. She compared 4 different cups, testing each of them 8 different times. Each time she heated water to 180 degrees, poured it into a cup, and sealed it. After 30 minutes, she measured the temperature again and recorded the difference in temperature. The data set is located in StatCrunch titled Cups. All right. So first of all, context. Context is everything. this is one, because its differences actually has a really interesting context. What does a small temperature difference mean in this context? So and specifically, what does that say about the cup? So if I have a value that is 1 degree, what does that say about the cup? All right. She heated water to 180 degrees, poured it in a cup, sealed it. After 30 minutes, she measured the temperature again and recorded the difference. The difference would always be from 180 degrees. So if she recorded a temperature of 180 degrees initially, which all of them were, and then 30 minutes later recorded a temperature of 179 degrees, the value would be 1 degree. What does that mean about that cup?
Cup is insulated.
The cup did very well. So actually, this is kind of a reverse. Low numbers are really good here, right? It's like golf, okay? Small numbers mean the cup is keeping the liquid hotter, right? If the number was 50 degrees, that means that cup sucked, all right? Because it cooled 50 degrees in 30 minutes, right? Do we understand? Okay, so it's always important to understand, right, when we read the problem, what are we talking about? All right, so small difference. The cup kept the liquid hot. All right, what are the shapes of the distribution? Given the majority of the shapes of the distribution, where the appropriate measure is center spread, compare across grids Y, which cup is best? Okay, so cups.
I found it on page 7 for me.
Page 7? Okay. Oh, you guys already got, oh, you guys are on it, huh? Okay.
We found this one
You
apparently.
found this one easy.
Maybe they're free, not so much.
Okay. This, actually, notice the data set here is different than the data set we just looked at. Those were side by side. This one, all right, has data entered column-wise. So in this column, it has the differences, all right, and then it's grouped by the container. So when we go in, first things first, shapes. You select difference, but now I'm actually going to use the group by container. This then gives me a bunch of graphs. So cups, 1, 2, 3. Oh, did we only have 4? I thought it was said 8. Oh, 4 different cups, 8 times. Okay. All right. So we need to identify the shapes. Okay. So for cups, whatever brand this cups is. Okay. So brand cups. All right. What's the shape?
You forget the name, sorry. Skew.
Skewed?
One, unimodal.
Unimodal. Skewed. We need one more piece of info.
Right.
Right direction. With skewed, always make sure we have a direction. Unimodal, right, skewed. Okay. Nissan. Nissan.
Yeah, I want to say unimodal, but
Yeah, unimodal. Again, there's no reason there's going to be bimodal here. And this is really close. There's only a 1 value difference here. 1, 2, which means, again, data not perfect. Once again, unimodal, right skewed.
bimodal.
This one, if anything, I could say, I mean, bimodal. This cup's basically what this says. The reason here, this might be bimodal because apparently this cup might be inconsistently as it's made. It's just my guess. All right. This is almost uniform because actually there's only 1 value difference here. So, I mean, I could almost say that's uniform too. All right. And then lastly,
Unimodal, right?
unimodal right skewed. Okay. So at least 3 of the cups. All right. So at least 3 of the cups are unimodal, right skewed. We could debate on what the last cup is, but it doesn't actually matter because when comparing lots of groups, given the majority of the shapes, so it doesn't matter if there was 3 or 4, all right, we're already at a majority. Given the majority of the shapes, what are the appropriate measures of center and spread and why? When we have unimodal and right skewed distributions, what's the measure of center and spread? Remember, Dale?
Means, what does the SD stand for again?
Is it mean a standard deviation?
Oh, wait, no, I'm sorry. The mean in IQR.
Median and IQR,
Median in IQR.
right? And it's always this, right? Basically, this is something that goes right on your cheat sheet. I have right skewed, median IQR. Why?
Because they just go together. They are persistent.
They are resistant to outliers. It's always this, all right? There are only these cases, all right? The complicated case is the one that you have to really do some thinking for, right? For bimodal and stuff. But these ones, basically, it always is this situation. Okay, median and IQR, since they are resistant to outliers. All right, and then lastly, which cup is the best? So the best way to determine that is a box plot. So same thing, graph, box plot, difference, group by container. So given our box plot looks like this, which one is best?
Nissan?
Yeah, because remember what best is. We're doing golf, right? Low is the best. That means that this kept the liquid hotter during this period. All right. So we want low numbers. And all right, this is actually the best for multiple reasons. Not only does it have the lowest median temperature, it's also the most consistent. The big box parts of these box plots means that these cups are actually kind of inconsistent. Sometimes they do a good job, sometimes not so much. This one kept all the values warmer and the most consistently. There's the least variation between these multiple trials, right? You don't want just one occasionally, right? Let's say we're doing 7 days a week. I don't want just 1 day a week to make sure I have a hot cup of coffee. I want it consistently every single day. And so this is actually the best for 2 reasons. It is the most consistent and it has the lowest value. Now, as a note, if I was comparing, I mean, these are actually pretty much the same cups, and Starbucks cups, right, are almost exactly spread the same, right? They have about the same median and they have about the same spread. But in the comparison, like, it's a judgment call. If one has a lower median, but the one with the lower median has a larger spread, all right, that's a judgment call of which one you think would be better. All right, and that can be argued either way. Okay, this is the gray area of statistics. You'd be like, well, this one doesn't quite keep them as warm, but it more consistently keeps those that it does keep warm, right? This one occasionally does a little better, but it's way more inconsistent. And so that's an argument of what you want. All right. So the Nissan, and I don't know if it's Nissan or Nissan. The Nissan Cup has the lowest median temp difference. And is the most consistent. AKA smallest spread. Smallest IQR. So again, the justification is the same. Center and spread. In statistics, we compare what's happening, right, on average. Yes, everyone is a snowflake, but that's not how you make a comparison. What happens to the majority of things? And that's what we do in statistics. All right, what can go wrong? Watch out for categorical variables that are masquerading as quantitative variables. That is male and female. We're going to talk about that next class. Beware of outliers. All right, we saw. And biggest thing, don't make a histogram on a categorical variable. That's going to be pie charts and bar charts. But histogram is our go-to picture for quantitative data. All right, I know that was kind of a long lecture, but you guys did fantastic. The data activity one has all kinds of awesome problems. Next week, all right, we are going to be doing categorical analysis, and we're doing that all week. I mean, we have one more week, and then it's quiz time.
Yay.
All right?
Oh, this will be fun. I can actually do the problems now.